Alrighty. These first two examples, complete and total review. You've got that perfect square sitting there. That's awesome. What do you square to get 7? Either positive or negative is square root of 7. So if I subtracted 3 from both sides, subtracted 3 from both sides, added 3 to both sides, come back and divide both sides by 2. There's what x could be. And remember, I always get nervous that you're not going to realize that's two different numbers. It's 3 plus root 7 all over 2 or 3 minus root 7 all over 2. Okay? Same thing here. What do you square to get negative 4? Well, you have to square an imaginary to get a negative. So either positive or negative 2i, and then put the real number first, imaginary second. Okay, now knowing that we can work with a square like this is handy if something like this occurs, because if you can recognize perfect square trinomials, okay, there's a chance this is a perfect square trinomial because the front and back are both perfect squares. If it were, it'd be x plus the middle, 2x and 2x. It is. So if you spot a perfect square trinomial, then we can set it up in the exact same way. Okay, so same deal here. 3w and 1, 3w and 3w does make 6w, so that's a perfect square trinomial. What do I square to get negative 18? Will be plus or minus the square root of negative 18. So I'm going to subtract 1 from both sides. Square root 18. Okay, 18 is 9 times 2, so that's 3 root 2, but you got a negative under the square root. And I'm going to come through and divide both sides by 3. But it'll usually look like that when it's typed up so that the I is not under the radical. Now, notice up here, I got a common denominator. Oops, a common denominator. Because it was a real number. That's a complex number. It's an imaginary number. So I need to separate out every single imaginary number you write is going to be in the form a plus bi, where a is the real part, b, well, a and b are both real, but a is the real part of the number, and bi is the imaginary part of the number. So you do not want to make that one big fraction. Okay. All right. So, like I said, we've noticed if these perfect squares show up, awesome. However, sometimes, it might not just be there on its own. So we will create our own. And it's all about spotting a pattern. Like if you multiply out x plus 3 times x plus 3. Remember, that's x squared plus 3x plus 3x plus 9. These two come together. You square that front and back. That's in there twice. By the time we make it to algebra 2, we're hoping that y'all don't have to actually write it out and multiply it out anymore. Like you've squared a binomial so many times that you have completely noticed the pattern, and we can just go. So, sorry, blow up my nose. If you got x minus 6 all squared, it's going to be an x squared minus 12x plus 36. This one, x squared, 2/3 and 2/3. There's 4/3 x plus 4/9. X squared minus 2/5 x plus 1/25. Like we want that to just come natural. If it doesn't, let's work on it. Because it kind of needs to. But we're sort of looking for the pattern about sorry. Well, there it goes. How do all the numbers relate back and forth to each other? So we were just going from here to here and seeing how these numbers relate. You do that twice, it's the middle number, square the back when it's the back. We've been going from this side this way when we're factoring. You notice it's a perfect square trinomial. But what if we just look for how do these, let me get rid of all my underline, I keep underlining things. How does this and this relate to each other. And in a way, how does it get back to here? So look at the middle number first, the one that's the coefficient on that linear term. And the reason I said a linear term is because it's on the x to the first. If it's just a function with an x to the first in it, it's going to be a linear function. So a lot of people call that the linear term. Notice how it's always double what's here, or if you thought it the other way, whatever sits here is half that. And if you relate these two to each other, if you half that 6 and square it, you get that 9. If you half that negative 12 and square it, you get 36. Half of 4/3 is 2/3. And you square it, you get 4/9. Half of negative 2/5 is negative 1/5. And you square it, and you get 1/25. So when you multiply out a perfect square, like the A, B, C, the B, if you half it and square it, you get the C. Okay, that's the key to what we're going to do today, is noticing that pattern. So we're going to figure out, find the value C that completes the square. So we're trying to figure out what goes here so that this is a perfect square. Okay. Well, look what it is. If I half this and square it, I get that. So it's half of 6, square it. If I put a 9 right there, this is a perfect square. And when you write it back as a perfect square, and then as a binomial getting squared, whatever sits here is always half of what was sitting there. Okay? So this one, z squared minus 10z, I want it to be a perfect square. Half of negative 10 is negative 5. Square that, it's 25. And then whatever that back half is whatever it was when I half the negative 10. So it's just, we're practicing them all. X squared minus 34x is what all squared, what number would have to sit where C is? Half of negative 34 is negative 17. If I square negative 17, I get positive 289. And that's an x minus 17 all squared. This one, r squared plus 32r plus something gives me some perfect square. I'm pretty sure I know this. Yeah, I know this. I'm still going to double check it on my calculator. Half 32, 16, and 16 squared is 256. Can't believe I'm double checking that. I do 16 squared all the time. I'm still checking. Yep, it is. So this would be an r plus 16 all squared. So, the C would be 256 here. The C would have been 289. The C would have been 25. R squared minus 6r plus something is a perfect square. Half of negative 6 is negative 3. Square it is 9. R minus 3. R squared plus 20r plus what gives me a perfect square? Half of 20 is 10. Square it's 100. It's an r plus 10. X squared minus 38x plus what would have given me a perfect square? Let's see, half that's negative 19. Is that 361? Yeah. X minus 19. A squared plus 12a plus what makes a perfect square? Half 12, 6. Square it's 36. A plus 6 all squared. All right. Are there any more? They're even. Here's one. M squared plus 40m plus what is a perfect square? Half of 40 is 20. 20 squared is 400. That's going to make it m plus 20 all squared. So there's any more that I have just an 8. Here we go. A squared minus 8a plus what makes a perfect square? Half that's negative 4. Square at 16. That's an a minus 4. All right. So what they're doing, all the ones that had an even coefficient in front of the linear term. All right, so we got all the first A. Let's do the odd ones next. So look at number 10. A squared minus 7a plus what makes a perfect square? So it's the same thing. You half the coefficient on the linear term, and you square that. So you get 49 fourths. And then what's going back in here is always what you got when you half that coefficient. So this one, m squared plus 3m plus what makes a perfect square? Half of 3 is 3/2. Square it, 9/4. This one, x squared plus 13x plus what makes a perfect square? Half of 13, square it. 169/4. See, x plus 13/2, all squared. Here's another odd. That's a -1. X squared plus x plus what makes this perfect square? Half of -1 squared. That's a 1/4. So x minus a half, all squared. All right, the rest are all fractions. Again, don't make this difficult. It's just a fraction. Quit being scared of them. Okay. Half -25/13. Well, when you half a fraction, you multiply by half. That's just -25/26. And then we're going to take that -25/26 and we're going to square it. So that's 625. I don't know 26 squared. Over 6. Yeah, I did. I knew that. Darn. Over 676. So you half and square it. Doesn't matter if it's a fraction or not. And then when you half this, you got -25/26. This one, z squared plus 11/8z plus what makes a perfect square? Well, half of 11/8 is 11/16. Square that. That's 121/256. Oops, on x. And then half that again, 11/16. Here's one. N squared minus a half n plus what makes this perfect square? Half of -1/2 is -1/4. Square that, 1/16. Yep. X squared plus 7/13 plus what makes a perfect square? Half of 7/13 is 7/26. Square it. We got 49/676. So half. All right. Now that seems silly, I know, but hopefully by the time you do it that many times, it's in there. So here's what we've figured out. If I tried to factor this, can you find two numbers that multiply to be -3 and add to be -6? Okay. There is no way I'm making a 6 of any type. So not all trinomials will factor. It's not a perfect square trinomial. I got -3 sitting there. But what I can do is create my own perfect square like we just did. Okay? So what I'm going to do is move the constant over here out of the way. I'm going to look at what's sitting here. And I'm going to go, well, half of -6 is -3. And if I square that, I get a 9. So I'm going to throw a 9 over there on the left side. Because I can. But I got to balance it out. Remember, an equation is like a seesaw. It's got to stay balanced. If you add 9 to the left, you better add 9 to the right. Because what you just did then is create your own perfect square. That's an x minus 3 all squared. And now we're back to what we've been doing for a week. 4 times 3, so that's 2√3. That's how you solve that one. And what we just did, that's called solving by completing the square. We created our own square. We completed one. The key to getting it right is realizing just how an equation works. If I add something on one side, I have to add the other. I can't just throw in that 9 and think it's not going to change things up. Like all the ones I just did, yeah, we just threw in a number because that's what the question asks. Like, what would C have to be to create this perfect square? I have an equation. The left side equals the right side. The left side equals 0. The right side equals 0. I can't just pick it up. Like when I move from here to here, it's because I added 3 to both sides. And then now I added 9 to both sides to create what I wanted to have. Okay, so we'll do the same thing here. Half of 6 is 3. Square it. That's 9. I'm going to add 9 to both sides. This is an x plus 3 all squared. This is a -4. And I got it. Okay. X squared minus 5x is negative 1. So I've moved the constant over there out of the way so I can complete the square. Half of 5 and then square it. 25/4. So the perfect square I just created over here is x minus 5/2. Now if I get a common denominator, there's 21/4. And you're saying, what did you square to get that 21/4? Well, it's either positive or negative square root of 21/4. So if I bring the 5/2 back to this side, square root of 21, don't know. Square root of 4, I do. And this you might see written as one big fraction, which is fine because you don't, none of them are imaginary, so you're good. All right. This problem, I'm going to leave the 4 over here. I'm going to bring the 8x back to this side. So I'm getting my variables on the left, constants on the right. And then same deal. I'm going to create my own square over here. Half of 8's 4, square it's 16. This is an x plus 4 all squared. Here's a 20. Twenty is 4 times 5. Okay. All right. Now, here's the thing you got to know about this one. When we were doing this pattern on this whole page up here, did you notice a lead coefficient of anything but 1? Yeah, you didn't, because that pattern only works if there's a lead coefficient of 1. So for this, I've got to divide both sides by 2 before I ever start. Then I can take care of business. So there's a 1 out here. Half of that squared. So this is a y plus a half, all squared. I get a common denominator over here. That's going to be negative 10 plus 1. That's negative 9/4. Squared 9/4 is 3/2, but it's got to be an imaginary because you squared it and got a negative. So subtract the negative 1/2 from both sides. And there's your answer. Do not write that one as with a common denominator. And don't let that I get in the denominator either. It's like my coefficient up front is 3i. My coefficient up front is 3/2, sorry. All right, this one, I'm going to divide everything by 3 first. Or not everything, both sides by 3. So then 2x squared plus 10x is negative 8. I'm going to divide both sides by 2 now. And then I'm going to complete my square. Half of 5 is 5/2. Square it is 25/4. So this is an x plus 5/2 all squared. Common denominator. That's going to be positive 9/4. X is negative 5/2 plus or minus 3/2. You don't stop on this one. We can keep going. Negative 5 plus 3 is negative 2. Negative 5 minus 3 is negative 8, but they're both over 2. So we're either going to get a negative 1 or a negative 4.